We're now going to dive a bit more deeply into posting and processing runnables with the Android handler and HaMeR framework. So this is going to kind of zoom in on a piece of this and talk about how we can use handlers to post and process these things with the HaMeR framework. We're also going to see how the message queue is associated with the threads looper. We're going to look at this code in just a little bit more detail. All right, so we all sort of know what a handler does. In this context, the handler is used to post and remove runnable commands. We'll ignore the send message part for a second. So these work on a message queue that's associated with a handler and a looper. And here's the typical use case. You create some kind of runnable and you post it to some kind of handler. Now, if you take a look, this is sort of just showing you the flow of control. The client will create a runnable and it'll call post, and that'll end up going inside the HaMeR framework where the dispatch message method is called, and that does some magic, moves things to into the right context, and then calls run, and that runs in another thread of control. Each runnable is dequeued and its run hook method is dispatched, so that's how the work's getting done. Under the hood, this is implementing something called the command processor pattern. And command processor is described various places. It's described in the POSA 1 book. It's described in this paper. And basically, it takes commands. If you remember the Gang of 4 command pattern from the POSA, from the CS251 book, where we talked about it from the Gang of 4 book, it basically defines methods with names like execute or run, something really simple. And it queues stuff up. A command is just put someplace and run at a different point in time, or it's stuck into an array of menu items, and then it's executed when you click on a button or whatever. So the command processor pattern takes commands and it goes a little further, and it talks about being able to enqueue them on a command processor, which will then go ahead and execute them in some other context, either later at a different point in time, a different process, different thread, different machine, whatever it is. So this is a pattern that, and basically the Java Executor framework, the Android HaMeR framework, they all implement this pattern. There are lots of other examples of this pattern too, but those are good ones from the context of Java. All right, so there are two categories of handler methods that we can use for posting runnables. Here's a bunch of them. They're all called post in one way or another. So there's some methods that are used to post runnables that run as soon as possible. Post puts it at the rear of the message queue. Post at front of queue puts the thing at the front of the queue, so it goes earlier. Then there's also one where you can give a relative time, which is basically relative to now. So you can say post this and run this in 2 seconds. And then there's also one where you can post something in absolute time, where you can give it a time. It's basically used by taking the current time of day and adding some delta to it. These obviously both support timed methods. You can also get runnables off this stuff. You can remove a runnable. If you put a runnable on, you can come back later and remove it. Obviously, if it's been dispatched, you're not going to remove it. But if it hasn't been dispatched, it'll be taken off the queue. And then you can also go ahead and look it up with its token. You can put things on there via other means than just runnables. And so you can look it up with the token. All right. So here's a simple example that's also kind of cool because it'll teach you a little bit about how Android works under the hood with some of the mechanisms that you're perhaps familiar with. So there's a method which you need to use for the current assignment, finishing up assignment 3, called run on user interface thread or run on UI thread. And you give it a runnable to run. And that runnable ends up running in the user interface thread no matter where the call came from to run it in the user interface thread. So we're going to take a look at the Android activity class, and it uses a handler internally in order to be able to dispatch the run hook method. So I'm going to show you a little bit about how activities work. So you can go ahead and grab the source code for Android. If you want to see this stuff, I'll just give you a quick tour through the parts that matter. So you all know what an activity is. You've used activity a couple times. You used it for the first assignment. You're going to use it for the next assignment, assignment number 4. And basically what an activity does is it gives you a single user-focused thing to do, right? Like run something to display images on a screen or whatnot. There are lots and lots and lots and lots of methods in activity, probably scores of them, more than dozens, there's scores. Some of the methods define callback hooks for user interface processing. So there's a whole bunch of things that you can define as callbacks, like what happens when users touch the screen in various ways. You can define things that are called back. What happens when someone presses the back button, dealing with fragments, configuration changes, like when you swivel the device from landscape to portrait mode and so on. And then there's also a pile of other methods that deal with the life cycle of the activity. We've talked about those too, like on start, on stop, on pause, on resume, all those kinds of good things. OK, so all the activity methods run in the user interface thread. So that's number one. They have to do that because that's what activities are all about, right? They're user interface focused things. Background threads can also communicate with the user interface thread by giving them runnables to process. So if you have something you need to have done, like you've downloaded an image and now you want it to be displayed, you can tell the Android framework, run this command in the context of the user interface thread. Well, the way it does that is it has something called run on UI thread, which executes a command in the user interface thread. And the command's called an action, but it's basically a command. And here's a simple example. This is an example from the download image program that we're going to look at. And we'll take a look and see more of this stuff. But basically, there's something in here called display image. And there's a method called run on UI thread that gets called with the new runnable. And it does a bunch of things. Now, if you take a look inside the Android activity class, you'll see that there's actually a handler created. So this is a handler called innocuously mHandler, which is a new handler. And this guy gets created in the context of the user interface thread. And what that means is the constructor for handler will register this handler with the user interface thread's looper. So this handler is associated with the user interface thread. And then it's got a method called run on UI thread, as you can see here. And what run on UI thread does is when you call it, it checks to see if the current thread is the user interface thread or not. And if it is if it is the user interface thread, then it goes ahead and just invokes the run method on the runnable command directly because it's already in the user interface thread. So there's no need to change context. Conversely, if it's not in the user interface thread, if it's in a background thread, which is the only other thread there could be in this context, it turns around and it posts the command via the handler. So you can see this gets posted via the handler. And we'll take a look and see what happens under the hood in just a second. This use of post, of course, is not limited to activity. It's used all over the place. But this is just an example of how posting to a handler is used by the activity. So when you use activity and you want to run something on the user interface thread, this is what happens under the hood. Now, there's something else kind of interesting to know about in this context. And that is that the post method, which could be accessed via run on UI thread or not, whatever it's done, actually leverages the Java local class capabilities. So basically, Java has this local class mechanism, and we've seen examples of this before. And what you can do here is you can declare things as final, and then you can access them inside of local classes that you define. This is a variant of something. Whoops, that's pretty weird looking. Better go back and fix that. I don't know what happened there. This provides a variant of something called a closure. So a closure is basically a method that also contains its runtime environment or its context. And that context can include non-local variables. And we'll see here how this gets used. So if you take a look at closure, you'll read more about closures. The actual kind of closures that Java supports are actually known as local classes. It's not quite as powerful as a full-blown closure, but it's pretty close. And basically what it allows you to do is if you create yourself an instance of an anonymous class here, right? So here is the closure that we're creating. This closure can actually access a variable that is outside of its scope. It's what's called the enclosing scope. So this closure, or this local class, is in the context or the environment of this display image method. And so since this bitmap image is a final parameter, we can reference it down here in this closure. And this thing, as you can see, is going to be created, stuck into the message dispatching loop, and then run in the user interface thread. And when it runs in the user interface thread, the image it refers to is the image that was passed in here. So this guy will live around, stay around long enough for him to be used inside the user interface thread, which is a totally different context where the thing was actually originally created and passed in the first place. Yes, Robbie?
So the final keyword just means that the underlying reference can't be changed, but you can still mutate the object, right?
You probably could mutate the object. I think it means read-only reference or something like that.
Because I was just going to say, like, if you mutated it before, the run method got called, would it show the previous, or would it reflect those changes?
It should reflect the changes, but we should test that out just to make sure. Here's a little bit more detail about what things do under the hood. So we're going to kind of see what happens when all these things get called. So when the activities run on a UI thread method gets called, that calls post. And here's what post does. So now we're peeking inside of the handler. So post turns around and calls send message delayed. And it calls send message delayed on a call to get post message. And here's get post message. Get post message takes a runnable, and it basically gets a new message, and it sticks the runnable as the callback field in that message, and then returns that message. So that's what gets sent to send message delayed. Under the hood, send message delayed ultimately calls send message at time. Here is send message at time. Send message at time grabs the queue, which is the thread-specific queue we talked about. It makes the target of the message be this handler, and then it goes ahead and enqueues the message on the message queue. So that message, which contains a runnable, has now been enqueued on the message queue. Then, in a different thread of control, now we're back in the user interface thread, no longer in the background thread. We're in the looper. This is going to be running the user interface thread. And the loop method, as you recall, blocks, waiting for the next message to show up. We just sent it a message because we posted something. And that turns around and then does dispatch message on the target. Dispatch message will check to see if callback is not equal to null. Now, in this case, it will not be equal to null because we just set callback in the earlier call to send message at time. And it'll go ahead and call handle callback. Handle callback takes the message, goes and finds its callback, which is a runnable, and calls the run hook method. And in this case, the run hook method will go ahead and run and display the image or whatever it's going to do. So that's just showing the sequence of steps that take place in the user interface thread. Notice the inversion of control here. I like that image for inversion of control. We're having the event loop run by somebody else, and that event loop will grab the next message, and then it'll block in a dispatch. So we don't own the event loop. The looper owns the event loop, and it's calling back to the message, which is calling back to the run hook method, which is eventually calling back to your code, right? So your code is being dispatched through those callbacks. So you don't have to worry about the control flow. That's handled for you. That's one of the canonical features of a framework. It owns the event loop. It drives the control flow. Later, we'll look at the entire code path, but you get the basic idea. All right, what I want to do last but not least with this section is show you the implementation of download with Runnable, which you can download here. And this is the part of the code when you click the run Runnable method, it goes ahead and downloads the image by using a Runnable. And so we have the handle button click on click message, and that ends up calling into this method here. And that uses the HaMeR framework, which starts things in the background thread. So the message is downloaded in the background. It prints basically a little sort of toast saying, hey, I'm downloading things in the background. And when it's all done, it passes the result to the handler that runs in the user interface thread, which goes ahead and displays the message, or it displays the image that was downloaded. All right, so let me go ahead and show you. Oh, that was nice. It went ahead and crashed at just the exact right time. Pretty cool. Doesn't usually do that. All right. So if you recall, when we were talking about all this stuff last time, we had looked at the main program, which was this guy. And the main program, if you recall, had set up a button strategy mapper, and the button strategy mapper mapped the buttons to the various strategies, depending on what you were going to click on. And the main method, which is called handle button click, gets a context, which keeps track of all the things that we need for our strategy. And then it goes ahead and gets the right strategy object, and it calls the download and display image method on the strategy object that was associated with the button that was clicked. So that's what we talked about up to this point. So now, let's assume we're doing the Runnable guy. So here is download with Runnable. And you can see that download with Runnable implements the button strategy. There's the button strategy. So it has two methods, download and display image and cancel download. So download with Runnable has that. It also has a thread object that's going to be used for downloading. We'll see how that gets set here in just a second. When the download and display image method gets called, it makes a new Runnable. And as you can see here, the new Runnable that gets created will turn around and create a run method that will download the image using the URL that was passed in by the user when they type that in, or it uses the default. And it gets this download image method from the context. Remember, the strategy pattern has a context, so there's the context. The context keeps track of all the methods and other associated data that is needed by a strategy to do its thing. So download context, download image, that gets us an image. Once we've got the image, we say, download context, please display this image, and here's the image. And this is a run method, and so this is the Runnable. And then we come in here, that's just, we haven't started anything yet, we just went ahead and created the Runnable. Then we create a toast saying we're downloading stuff. We make ourselves a new thread, and that thread will run the Runnable that we just looked at, so that'll go ahead and do this stuff. It'll download the image, and then it'll tell the download context to display it. We'll relook at that code in just a second. Then we start this thread, and the reason that we keep track of the thread here is because we also have the cancel download method. So the cancel download method allows you to interrupt a thread that may already be running. So if we start a download and then decide between when we start it and when we get the image downloaded, we don't want to do that anymore, then we can cancel it, and that'll cause the thread to stop. Cooperatively, of course, using all the good interrupt mechanisms in Java. So that's cancel download, and you can see up here, all we're doing is we're just basically creating a Runnable and starting it a new thread, and it does the stuff in the background, and when it's done, it goes ahead and calls display image. And if we look over here at download context, then display image does the clever thing that I showed you earlier. What it does is it checks to see whether or not we're already on the user interface thread, and if we are, it goes ahead and displays the image by simply telling the image view to set the image, the bitmap, to whatever we pass it. If it's not running on the user interface thread, then it goes ahead and it makes a new command, just like we looked at, using the local class closure-like stuff. And that command has a run method that will go ahead and be queued up to run on the user interface thread's message queue by its message loop, by the looper. And when the run method gets called back there, it will be running in the user interface thread. It'll recursively call display image, which will then turn out to be true, which is the base case of the recursion, and that'll set the image here. So pretty cool, bunch of different things. OK, so just to kind of take stock of where we are, we talked about message. We talked about messages and runnables. I showed you some details about runnables. On Wednesday, we'll talk about messages, very simple. And then we'll talk about async tasks, hopefully on Wednesday as well. And what I want to have us do now is turn it over to Mitchell, who will talk about the next assignment. So now that we went and covered the various implementation artifacts in the context of the threaded downloads application, if you recall, we talked about sort of the way in which you could do posting runnables with that. What we're going to do is talk more generally about usage considerations for using post and the family of post messages. So post methods form a key portion of the framework. They're basically used for enqueuing runnables that are intended to be processed at some point. You can do it in FIFO order. The next one up gets to run, or you can do it based on the passage of time, either relative time or absolute time. And you can pass these runnables using the framework either within a single thread to itself, which is typically used for timers or time-related operations, or you can also do it from one thread to another, which is typically used when you have a background thread that wants to talk to the user interface thread. That's the typical thing. You send commands like that. Under the hood, all these things work together to apply this pattern called command processor. We'll talk more about that later, or you can look at it online if we don't get that far in the semester. So let's talk a little bit about what commands do. They centralize the processing logic at the point where post is called. So the idea here is we're coming along, we've got something to do, we're going to display an image, etc. And at the point where we're going to do the post, which in this case is just underneath the implementation of run on UI thread, when we're going to do the post, we know what we want to have done, but we want it to be done in a different context or at a different time. So the minute you know what command you want to execute, but you want to defer where or when it's executed, the command processor pattern is the pattern for you. Some things to note, this pattern is very heavily used when there's one-way operations. They don't necessarily return a result. They're just used to send a command that's processed in a different context. So as a consequence, there's no receiver logic needed to handle post because the runnable, which is this closure or local class, carries its context with it such that when the receiver gets it in the event loop of the looper thread where the handler runs, it simply can dispatch it and call its run method. So the sender creates the closure with the run method. When it gets to its destination, the receiver just calls back run. There's nothing the receiver does other than just say run yourself. And that's what makes it a closure. OK. We use the activity class as a motivator to show why this is a useful feature in Android. And if you recall, we called run on UI thread, which used a handler to pass the runnable, which then gets executed either in the background thread or the foreground thread or whatever.